Welcome. Today I'm joined by a very old friend and colleague, electronics evangelist, Joe Fjelstad. Great to meet you, Joe.
Yeah, very old is right. I'm very old.
I think we both got rights in that one. But you know, you've been in the industry a long time. You've had a phenomenal career, and one day I would actually like to do your biography, quite frankly, and because you have had so many different chapters and things that have happened, and it's an amazing story. But I really want to feature on some of the stuff you're doing today and some of the stuff that you are working on at the moment. One of the biggest projects you've had in the last decade really has been the OCAM project, where you want to use solderless assembly. I'm sure everybody in this industry has heard of OCAM.
Maybe not.
Maybe not. So give us an overview very quickly. Give us the 1,000-foot view of what OCAM technology is.
Very good. It was fundamentally the genesis was, as you may know, there were I and others who, in the run-up to lead-free, did some analysis of the issues and decided that lead-free was actually the end.
It was a political decision.
Yeah, it was a political decision. It made no sense. Right. Engineering-wise, scientifically, I thought, this is crazy.
Cost a lot of money.
Exactly, $100 billion or more by some estimates. Yeah. And for no purpose, unless, of course, you were long on tin futures, in which case it played out pretty well. Yeah. And, you know, the demonstration of, you know, morbidity or mortality related to lead just wasn't there. And at the time, and I don't know what the numbers are today, but at the time I did a little bit of research and found out that lead in electronics represented less than 0.5% of all the lead used globally on an annual basis.
Right.
So, you know, I fought it and, you know, was caricatured as Don Quixote but, you know, I didn't have anybody that was going to muzzle me. Right. You know, kind of work on your own. You get to say what you want to say.
That's true.
So on the heels of the release of the mandate kicking in, I sat down one day and I was writing pretty regularly for you, as you may recall, and I wrote 3 words down: assembly without solder. As I was setting down, and I went, "Now there's an idea," you know. And it suddenly hit. It was almost, you know, like Venus, you know, coming fully formed from the oyster shell. And it said, yeah, this makes sense, and there's a way to do it. Right. You know, is essentially to build everything fundamentally backwards. Right. That is, rather than building a circuit board and putting components on it with solder, I thought, well, why not build a component board and put the circuits on it and eliminate the solder? So that's kind of where I am, and it struck me at the time. I had a long time fascination and interest in philosophy, and one of the influences from my early days was William of Ockham, one of your countrymen from a much earlier time, who was a logician and a monk. And I guess you get to be, if you're a monk, you get to be a logician at the same time, perhaps. Okay. But anyway, he said, you know, it's fundamentally, in a nutshell, it's vanity to do with more of that which can be done with less. Most people know him from Occam's razor, that given multiple potential explanations for any observed phenomenon, the simplest one is the one that's most likely to be correct. Right. So that's been where I'm at, and you know, in one sense, not much has changed. You know, and that's almost 12 years ago.
Well, you know, it is a very simple concept. I mean, it literally, you build it back to front, as you say. It's like almost like a compression sintering type process. Yep. But have you got any proof of concept?
Well, I've done some little demonstrations. I would, you know, bemoan the fact that, you know, if I was working for an old friend of mine that I worked for back in the early 80s, where I was running R&D in his facility, I would have been already done. Right. I would have already built, you know, multiple assemblies and demonstrations of this.
So what are the barriers then? What's stopping people?
There are no barriers. The barriers
well, it has to be.
The barriers are in imagination, for the most part. That most people, you know, believe that it can't be done. And, you know, I can't remember the exact Latin, but there was a Latin term that goes something to the effect, They think they can, therefore they can. All right. And so we're going back a couple thousand years. Is that for the most part, if you make a decision, we're used to it. We're creatures of habit.
Right.
And it's not a bad thing. I mean, it allows us to progress as we have for quite a time.
But I mean, the tooling costs for making a prototype can't be that bad.
It wouldn't be expensive in terms of demonstration. I spoke on TechNet, 10 years ago, how you could do it in your kitchen.
Right.
With simple, even with leaded components in that time. Mm-hmm. Take a piece of polyethylene, put a piece of cardboard underneath it, punch the component leads through that, cover it with a 5-minute epoxy, peel it off, trim the leads down, use a conductive ink, and boom, you got a circuit. It's that simple.
Incredible.
Right?
Okay, so I certainly wish you well with that project, and I mean, I think you've laid down the roadmap, as you said, for engineers in the future that want to take it up.
Exactly.
Let's take a look now with your crystal ball ahead, where you think technology is going to be leading us in the future.
Well, I think that the logic of this, which is I use Legos, the idea of a standard grid, having all the components there on a fundamental grid pitch with all their terminations. That's already been demonstrated by a good friend of mine, Darren Smith, to do a redesign of a product. He took from a product he'd already designed. He went from, it was 110 by 140 millimeters down to 12 layers. And then he took it to, I think it was something like 70 by 30, made it into a rigid flex so it could be folded, and it only took 6 metal layers.
Wow.
So that's the kind of potential there is. But I told him, don't go to DigiKey and look for components. I want you to pretend like the components exist.
Right.
So these are not impossible things to do.
So you're looking for components that have got more complexity, more of the circuit built into them, and you build them into...
Well, at some point in time, yeah. I mean, I've talked about, disintegrating circuits. In other words, going backwards in time. And allowing a designer to design a product with not the most transistors, but the least number of transistors required. Presently, a designer will pick a particular chip that he'll want to access a certain functional block on it. He has to wire everything up.
Right.
But he's only interested in this particular function IP block.
Yeah.
So that's the kind of thing. If we can get those IP blocks as actual components, some of these small form factor devices, QFNs and the like, and being able to build, you can pepper these structures with these devices and build something that's very small, very few in terms of, it might be, there's an issue of more terminations perhaps in one sense, but the layer counts with the routing and the rest of it, I think it's going to be superior. Wow. And I think, we need to build products. I've long been on talking about, who's the potential customer for this. Well, there's a lot of things that we do. The strange thing is, it's much easier to build things more complex than it is to make them simpler. That's just the nature of structures. But I've been it came to the epiphany, 12 years ago that what do military, aerospace, automotive, and medical product and users and developers have in common with the world's poorest people? And they both must have the most reliable products you can possibly make.
Right.
At the top, it's mission and application. At the bottom, it's because if you're making $2 a day, you can't afford the failures that the rest of us can. We'll go buy another one. No, they can't do that. So, providing those less fortunate or less fortunate by birth the opportunity to have the same kinds of benefits of electronics that allow them to do the kinds of things that we don't even think about anymore. To me, seems like it's kind of a moral imperative. So there's about 4 billion of them out there. So if you look at it from a marketing standpoint, it's not a bad market.
Not a bad market, no.
Yeah.
So let's put our hat on and take a look at AI and 5G coming down.
Yes.
What do you think that's going to bring us?
Well, I think AI is, Ray Kurzweil talks about, live long enough to live forever, and that's takes us to the singularity in 2040, I think is what he was talking about. Artificial intelligence is on a run, and it's going to show up. It's people get fearful of it, but I mean they've been talking about it for decades. I think the first movie I ever thought about that was like the Forbin Project. Right. They talk about machines or Space Odyssey, 2001. But machines have a logic to them, and their ability to collect the information with Google and all the information that's out there. they're going to be soaking this thing up, and they're going to be doing an analysis of what it is that's happening.
That's right, but it is a logic. I mean, and so I think in many cases at the moment it's really assisted intelligence. It's not actually artificial.
Well, maybe at this moment. But the thing is whether or not, I mean, there's always a concern will become, self-aware machines and the like. Who knows? I mean, the idea of being able to create this kind of architecture that's over. I mean, we're at this point, Star Trek is essentially already happening, if you will. It's we carry Star Trek around in our pockets and talk to it, whether it's Siri or what's a Google, whoever you want to talk to, Alexa, that they're all out there collecting this information for us, and then, of course, talking with us back and forth about what it is, making suggestions and the rest of it.
Whether we want it or not.
That's right, exactly. And and they of course know what we want, because the questions have been asked enough times that at a certain point in time.
I have a Google Home in my apartment in Florida, and I was on a telephone call with my daughter, I think it was, and we were talking about a certain product, and I finished the call, and about 20 minutes later I started getting advertisements coming through on the phone. And it's because my Google Home had picked it up.
Yes. And that's one of the reasons why I don't own one. I get nervous about that, because I do believe that we're on this cusp. I mean, I'm not a Luddite by any stretch of the imagination, but I do, like...
You're careful.
I do think that one needs to be prudent about these kinds of things. We've seen how things can, slip down the slope pretty quickly if we're not mindful about what we're doing. And I say it's not an issue of fear, it's an issue of, it's just prudence about where things are going. But I think that, it's going to be interesting. We live in interesting times. I understood that in China that was considered a curse. May the emperor know your name. May you get everything you ask for. So interesting times are a fascinating time. I'm feel blessed to have been hanging around that long as an old guy. And, there's still a lot more to see, I'm sure. But we'll see where it goes. I think there's a lot of, we're not done yet. Let's put it that way.
We're a long way from done, and there's a huge amount of tech, especially coming out of China.
Yeah.
Especially coming out of China. Fantastic, fascinating place. Joe, I want to thank you for joining us today. It's
my pleasure.
Great to have your insight.
Always a treat, Trevor. All right.
Okay.